Actually, it's more like a PAL chip. You know, we put our own little program in there. And what it does, it clears the RAM and it goes ahead and it communicates with the E-square on the backplane. And what this particular chip does is allow access to the E-square on the backplane to set the percentage and lock it in. So that's what we're going to do now. We're going to set that in place. Now on this particular one, I made a little black notch. Let's see if you can see it from, yeah. I know everybody's here. Anyway, I used a magic marker and put a little black dot on it. That way, I know it's going in the correct direction here. You don't want to put it in backwards because you can blow it up just like an EEPROM. And you want to make sure all your pins are in well. Hold the board by the sides. And let's go over. Normally you will be right here at the game. You're not going to be walking around with the board like that. Otherwise you could corrupt the RAM or blow up a component. Do the ESD. And plug the board in. Hook up the VGA plug. And let's power it up. Okay, here we got a problem.
What did you hear or see there?
Okay. Remember how I was saying that this LED down here, when that stays lit, there's also a LED up here on the I/O board. Now if both of those, if that stays lit, then there's a problem. It should light for a second and then turn off. Well, let's take a look here. Okay, the jumpers are in the right place.
Yeah. Well, is that pin bent under there?
Let's see.
Yeah. That pin's, oh, it's just wiped out from you using it so much.
Yeah, this is a pretty used up.
I don't see where you've mispinned it.
Okay, there's something else I've noticed.
That actually doesn't seem too much.
Right.
I just broke the seal.
That's good. One thing, that's a good point you just brought up there, Randy. You want to make sure that your EEPROMs are seated tight. Push, go ahead and, did you hear that snap?
You can really hear them snap. Yeah.
You want to hear a good snap when you push down on that EEPROM. Make sure it's in there good and tight. Otherwise, you're not going to get a good data connection. Now, another thing, we have the microprocessor, the ADC188, as you can see right here. Okay, that's more like the, you've heard of Intel Pentium processor for, you know, latest computers and all that. This is pretty much what it does. It processes all the data. It's routing it from here to there, and it gets reset signals. It tells it what the next command and interrupt function is supposed to be, etc. Okay, now if we can pop this out using a PLCC extractor tool.
PLCC, plastic leaded chip carrier. It's that square, that package.
Right.
There.
It's the square package. Everybody can see that?
Where are you on?
Got it?
Cool.
Okay. And pin 1, as, let's see, Randy was mentioning earlier, there's a, see this dot in the middle? Right there in the middle, there's a dot. Not the one by my thumb, but that one right there. I'm blocking everybody's view too. That's pin 1, and that goes at the top of the socket. And
Time to take a break.
yeah,
See, I'm out of take. We go one. I didn't tell you. We go 1 hour and then take a break.
Okay.
So can we do that right now?
Yeah, let's do that now. That's a good.
Let's take 10 then, and we'll pick up in a second. And we'll see if Ron really did break it. Okay, so when we last left our hero,
We laughed and left. Yeah.
we're going to see what he done did. We don't really know unless the chips were just loose, so let's try it again.
Right, and there's a lot of different problems that can cause that, where like if you worked on our game and you powered it up and the screen is black, you power it off and you see that white flash on the monitor, that usually means that your monitor is fine, but you have a data problem. One of your chips wasn't pushed in all the way, like you heard that snap when I pushed on XU3. That's a good scenario there. Let's try it again now. I'm going to put the XU27% key back into place. And we're going to go ahead and see if we can get this game to come up here again without the fail light. Now the thing that triggered it off to where I thought there was a problem when I first powered it up, I don't know if you can get this in. Okay, up towards the top here, there's a little LED right up there on the video I/O board.
Yeah, get down to it.
Right up there at the top. Now, when you power up your game, that should flash on for a second and turn off. That means everything's fine. If it stays on, then you have a data flow problem. It's locked up. You're not going to get any picture, you're just going to have a black screen. And that's one of the common problems with our game, I noticed. Okay, now let's see if see how it went on for a second and turned off? And there's the bong. So once you hear that one single bong, that's a good sound. So, yep. Aha, look at this. RAM signature corruption.
Okay, let me get on my page and I'll see it. Okay.
And this one.
Is that what you expected?
No, actually.
Okay.
But that's good that it is there, because this is one of the things I wanted to cover. When you get a RAM signature corruption, you got a main meter corruption. Let's see, what else we got there?
Just the two.
Meter, RAM signature, main, yep. And data lost. So somehow we lost some of our secure memory data. So we're going to have to re-RAM clear it. Now if you do that, you know, like more than one or two or maybe 3 times, and you have a bad CPU board. Maybe one of your RAM chips are bad. So we're going to try it again. I'm going to go ahead and reseat the video, because that is part of this power-up process. The video I/O board and the CPU board both communicate together. Okay, let's take the XU27% key back out. Take our XU3 game EEPROM out using our swing line staple EEPROM remover. And we will put in our RAM clear, verifying the notches on the right. Make sure it's snapped into place good and tight too. Well, I notice that really snaps in there. I want to check something. One thing you want to make sure of, that you don't bend any pins. If you bend a pin,
Oh yeah, is there one there?
it's not really,
Right there.
it's bent just a little bit, but it was in the socket. And I notice a lot of times you can take and straighten the pins out on the drop cabinet, the slot stand cabinet. And you can usually straighten the pins out fairly well like that. Has anybody ever worked on some of the old Bally games where they had these circular EEPROM sockets in them? Well, Bally, have you ever seen those?
No, I haven't. No.
The 5000 series, they used to have.
For the V5000?
Yes.
Jumped that. Videotape that, didn't I? They edit that part out.
Okay. Now let's try it again.
Not their most popular.
Okay, that snapped in pretty good. We're in the right polarity. Let's try another RAM clear.
Now, do you put the denom set or the percentage chip in there, you have to take that out to do the RAM clear?
Yes. When you do the RAM clear, make sure your percentage key is back out. That doesn't go in until you put your XU3 game EEPROM back in. Okay. Now, okay. Now, yeah. Notice how that, you got some tape on here. Let me take that off.
So it just misseated, you think?
Okay. Well, we don't know yet till we put the XU3 game EEPROM back in. We're going to re-RAM clear it right now. Okay, as you can see, we have the touch screen to clear RAM flashing back around again. So we'll touch it and wait a few seconds. The bong, there we go. Safe to power down. Okay, we power it back down. Well, CPU. And I usually hold it by the ejector tabs. Don't want to, even though we're not on any carpet surface, there still can be ESD generated. Oh, it just popped right out of there. Remind me to get a new RAM clear when I get back. I think I've about worn that one out. Snap, snap. So that was a good snap there into place. Now we're going to put the XU27% key back in and try and set the percentage again.
If you didn't take that out, would it clear the percentage of that?
It would still do a RAM clear, but you know, it's not a good idea to have that in there because it has information or access to the secure memory. So it's
What happens
recommended.
if you put it in without the denom set, without this one in there?
Oh, right now?
Yeah.
Oh, it'll be at its default percentage, which is 92% in this particular theme.
It doesn't go into a key chip because you can clear up back
No. So like, okay, now since this is a 92% game, on a lot of our themes, 92% is the default percentage. Okay, so I'm just going to plug this in without the XU27 key, assuming that's what it should be, is 92%. And that's what it is, as I verified before. All right. Were you able to see the?
I wasn't looking.
Okay.
It must have. Huh?
And yes, because the LED is out. Now, if that red LED was still on, we'd have a problem. Okay, now this is what you should get when you clear the RAM. You'll see a tilt memory cleared flashing. From there, we want to push the diagnostic button.
Wait a minute, let me get that.
Okay,
Go ahead.
right there, diagnostic configuration test switch. Which you can't see the switch, you can see the tag for it, but it's right up under there. Just push that once. And the memory clear quit flashing. Then you have to wait, it'll black out. Now it's doing its self-checking. It's checking all the peripherals. And in a few seconds you'll hear the bill validator start up. There it goes.
Well, almost like you knew what you were doing.
Yeah, like I've done it a few times. Okay, and then as you can see, we have our game screen. And we have a logic door open and a main door open hot dog tilt. Which, of course, we have the logic door open and the main door open. So we're looking good.
Now, why do we see this on the top, on the LCD?
Okay, that means the LCD is down right now. It's waiting for a signal from the game to come up. And the only way this is going to come up is if we close all the doors. So if we go ahead and we were to simulate the logic door being closed and the main door, and our LCD comes up. Now when we open the doors, we still have our display here. That's because it's already been initiated from the game. The game says, okay, everything's okay. Go ahead and initiate the liquid crystal display. And what that does, it has its own attract mode setting where it goes through different track modes. With the door open, you'll just see reel 'em in, cache for cache up there. Okay. Now, let's go ahead, before we get into our option settings, let's go to our workbooks. That's the comb binder one here. Okay, go to page 3 and page 4. Okay, just a few things we want to go over with on the CPU board. Make sure everybody gets familiar with it. Okay. Match the component number from drawing A with the numbered blanks below. Fill the numbered blanks below with the corresponding component name listed at the bottom of this page. Okay, let's start up here at number 2 in the upper left-hand corner. Anybody know what that is offhand? Yep, XU2. Okay, that's your... And we go down here, we've got Game EEPROM XU2. Now that's the Game Graphics EEPROM XU2. You can cross it out there and write it in here. XU2 EEPROM. Now that's associated with the game chip, but it is actually a graphics EEPROM. Most of your graphics information is on there. Okay, number 2. Well, the second one down over here on the page, we got 15. Anybody tell me what this XU3? And what does XU3 do? Game EEPROM, very good. And what kind of data does that usually store on it? Anybody know?
Isn't that the rules of the game, the program itself?
Right, the operating system, you know, the theme. Like this is a cache for cache. It pretty much tells it how the game will work. And it controls the graphics EEPROMs as well, XU2, 4, or 5. Okay, number 6 on the drawing. What do we have there?
It was blank on the
Yep,
one you showed us.
XU4. Yep. Okay, let's go down here. Graphics EEPROM, XU4. Now, as I was mentioning earlier, the XU4 is a graphics EEPROM that is used specifically with some of our newer themes that have require more graphics memory than, like, say, the cache for cache, for instance. We will use both XU4 and this chip right here, which is XU5. Yep, that's the other graphics. So each one of those are usually an 8 megabyte EEPROM. So if you add the two together, that's an extra 16 megabytes of video memory that you are adding, read-only memory that is, and it's usually theme specific that can be displayed on the screen. So you can figure that has more, you know, symbols and real symbols and pictures, and most of that type of, that's the type